Transformer installations in manufacturing production areas require careful consideration of several key factors to ensure safety and compliance with electrical codes and standards. Firstly, the placement of transformers on wooden pallets, especially in forklift traffic areas, presents significant safety concerns. The National Electrical Code (NEC) requires that electrical equipment be installed in a neat and workmanlike manner. A wooden pallet does not typically meet this requirement, especially in an industrial environment where equipment is expected to be robust and securely mounted. The primary concern is the potential for physical damage to the transformer from forklift traffic or other equipment. Transformers are heavy and can be unstable on a pallet, increasing the risk of tipping or falling, which could result in electrical hazards or physical injury. Secondly, the absence of guarding around the transformers poses a safety risk to personnel in the area. Transformers can have exposed energized parts, creating a potential for electrical shock. The NEC mandates guarding of live parts operating at 50 volts or more to protect against accidental contact. This guarding can be achieved through various means, such as enclosing the transformer in a cabinet, installing barriers around it, or elevating it to a height where it is inaccessible to unqualified persons. In a forklift traffic area, physical barriers are particularly important to prevent accidental contact with the transformer and its connections. Thirdly, the use of a 15-foot SAW cord directly into the primary of the transformer raises concerns about strain relief and mechanical protection. SAW cord is a flexible cord intended for portable applications and is not typically suitable for permanent wiring. The NEC requires that wiring methods be suitable for the environment in which they are installed. In an industrial setting, wiring methods should be robust and provide adequate mechanical protection to prevent damage from abrasion, impact, or other hazards. Furthermore, the length of the cord may create a tripping hazard and could be subject to physical damage from equipment or personnel. Fourthly, the method of disconnecting the transformer raises questions about compliance with safety standards. Each machine has its own means of disconnection, but the primary disconnect for the transformer is located in the 480-volt bus. It is essential to have a readily accessible disconnect switch near the transformer to de-energize it for maintenance or repair. The NEC requires that disconnect switches be readily accessible and clearly labeled to indicate their purpose. A disconnect located only at the 480-volt bus may not be readily accessible in all situations, particularly if the transformer is located some distance away. Fifthly, the practice of bonding the transformer to a driven ground rod through the concrete floor requires careful evaluation. While grounding is essential for electrical safety, the NEC specifies the methods for grounding and bonding electrical equipment. A ground rod is typically used as a supplemental grounding electrode and is not intended to be the primary grounding means for a transformer. The primary grounding path should be to the building's grounding electrode system, which is typically a metal water pipe, the building's structural steel, or a ground ring. Connecting the transformer solely to a ground rod may not provide a low-impedance ground path, which is necessary to facilitate the clearing of ground faults. To address these concerns, several steps should be taken to improve the safety and compliance of the transformer installations. Firstly, the transformer should be securely mounted on a suitable platform that provides stability and protection from physical damage. This could involve using a steel frame or enclosure that is anchored to the floor. The platform should be designed to withstand the weight of the transformer and any potential impact from forklifts or other equipment. Secondly, guarding should be installed around the transformers to prevent accidental contact with energized parts. This could involve using a wire mesh enclosure, a solid barrier, or a combination of both. The guarding should be designed to prevent access to the transformer by unqualified persons while still allowing access for authorized personnel for maintenance and inspection. Thirdly, the SAW cord should be replaced with a suitable wiring method that provides adequate mechanical protection. This could involve using conduit, cable tray, or another approved wiring method. The wiring method should be installed in accordance with the NEC and should be supported and secured to prevent strain on the connections. Fourthly, a readily accessible disconnect switch should be installed near each transformer to de-energize it for maintenance or repair. The disconnect switch should be clearly labeled to indicate its purpose and should be located within sight of the transformer or be capable of being locked in the open position. Fifthly, the grounding system should be evaluated to ensure that it complies with the NEC. The transformer should be grounded to the building's grounding electrode system, and the ground rod should be used as a supplemental grounding electrode. The grounding conductors should be sized and installed in accordance with the NEC. In addition to these specific recommendations, it is important to conduct a thorough electrical safety audit of the entire production flow to identify any other potential hazards. This audit should be conducted by a qualified electrical professional who is familiar with the NEC and other applicable safety standards. The audit should include a review of all electrical equipment, wiring methods, and grounding systems. Any identified hazards should be addressed promptly to ensure the safety of personnel and the integrity of the electrical system. Regular inspections and maintenance of the electrical system are also essential to prevent problems from developing. This includes inspecting transformers for signs of damage, checking connections for tightness, and testing grounding systems for continuity. By implementing these measures, the manufacturing company can significantly improve the safety and compliance of its transformer installations and create a safer working environment for its employees. The use of wooden pallets in a forklift area is not recommended. They are susceptible to damage, creating an unstable base for the transformer. Instead, consider using a concrete pad or a steel frame securely anchored to the floor. This provides a stable and durable platform that can withstand the rigors of the industrial environment. This approach aligns with the NEC requirement for neat and workmanlike installations, reducing the risk of accidents and ensuring the longevity of the equipment. Guarding is essential to prevent accidental contact with energized parts. Options include physical barriers like fences or enclosures made of metal or durable plastic. The height and design of the guarding should prevent easy access by unauthorized personnel while allowing qualified electricians to perform maintenance. Warning signs indicating the presence of high voltage should also be prominently displayed. According to NEC Article 450.21, transformers must be protected against physical damage. The guarding not only protects personnel but also prevents damage to the transformer itself. Flexible cords, such as silk cord, are generally not suitable for permanent wiring in industrial settings. They lack the mechanical protection required to withstand abrasion, impact, high exposure to chemicals, or other harsh conditions. Instead, consider using rigid metal conduit, intermediate metal conduit, or electrical metallic tubing end to provide a robust and durable wiring system. These wiring methods offer superior protection and are better suited for the demands of a manufacturing environment. Furthermore, ensure that all wiring is properly supported and secured to prevent strain on connections. A readily accessible disconnect switch is crucial for safety during maintenance or emergencies. The disconnect should be located within sight of the transformer or be lockable in the open position to prevent accidental re-energization. This allows workers to safely de-energize the transformer before performing any work on it. The disconnect should be clearly labeled to indicate its purpose and the equipment it serves. According to NEC 450.14, disconnects must be readily accessible. The NEC specifies the requirements for grounding and bonding electrical equipment to ensure safety and prevent electrical shock hazards. The primary grounding path should be to the building's grounding electrode system, not solely to a driven ground rod. The ground rod serves as a supplemental grounding electrode. Ensure that all grounding conductors are sized and installed in accordance with the NEC. Proper grounding provides a low impedance path for fault currents, allowing protective devices to quickly clear faults and prevent electrical hazards. The electrical safety audit should be conducted by a qualified electrical professional with experience in industrial settings. The auditor should review all aspects of the electrical system, including wiring methods, grounding, bonding, overcurrent protection, and equipment installations. The audit should identify any potential hazards or violations of the NEC or other applicable standards. A written report should be provided outlining the findings of the audit and recommendations for corrective action. Regular inspections and maintenance are essential for maintaining the safety and reliability of the electrical system. This includes inspecting transformers for signs of damage, such as oil leaks, corrosion, or overheating. Connections should be checked for tightness to prevent loose connections, which can lead to arcing and overheating. Grounding systems should be tested for continuity to ensure that they are providing a low impedance path for fault currents. Overcurrent protective devices, such as circuit breakers and fuses, should be tested to verify that they are operating correctly. By implementing these measures, the manufacturing company can create a safer working environment for its employees and protect its electrical equipment from damage. Attention should be given to Article 450 in the NEC, which covers transformers. Proper support is detailed in 450.10. Physical protection is important and is detailed in 450.21. Grounding is important and covered in NEC 450.10 and NEC 250.